Welcome back, everyone. Let's keep talking about CAP theorem. In the last video, we discussed consistency and partition tolerance in a distributed system. Now we're going to talk about availability and what it means for a system to be available. So let's go back to our example with our database being numerous nodes, as well as representing this financial institution with ATMs and balances. Let's say inside of here, we have a partition. Remember, I mentioned that in all distributed systems, you must assume that partitions are possible, i.e. failures in the network communication between these database nodes. So here, let's imagine that this bottom right node is not able to communicate with any other database node in our system, meaning that there is a partition that has happened here. Now, let's say Sarah makes that same transaction. She wants to remove $100 from her balance and give Matt $100. What happens in our system is that this transaction completes, and let's say it is also consistent with whatever nodes that this database was able to communicate to. So that bottom left one and the one that Sarah was directly communicating to both reflect the correct data. Sarah having a new balance of $900 and Matt with $100. Now, let's say Matt is in that bottom right corner and he is connecting to the ATM that is connected to the database that is partitioned from the entire other system. Here, when he tries to check his balance, he will see that he has $0. Now, the reason why this database, regardless of being partitioned from the rest of the system, still returns $0 is because this system is available, meaning that data always gets returned regardless of whether or not a partition is detected in the system. In a system that is unavailable, if there is a partition, this database cannot guarantee that it knows for sure that the data state it has is stale or up to date with any transactions that has happened throughout the system. So if that were the case, then it would throw an error, or maybe it would tell Matt that right now the system is down. You can imagine how you might go to an ATM and the ATM tells you that the system is down. If that is the case, then that system, that ATM, and the creator of that system has decided to create a system that is not as available. Because an available system will always give you back a value, regardless of whether or not the data is stale or not. The whole idea of an available system is to always provide back data, even if the data cannot be guaranteed to be the latest and freshest data. So if your system prioritizes availability, then that's what you're doing. You are always returning back data, even if it's stale. So if you have a system that is both available and partition tolerant, then you have an AP system. So this is the CAP theorem. Essentially, you are choosing between either consistency and partition tolerance or availability and partition tolerance. Now, earlier, you do remember that I did talk about a system that is both consistent and available, a CA system. How does a CA system work? It's very simple. Essentially, a CA system is not a distributed system. You only have one central node that represents the database for your entire system. So here, any ATM all connects to one node. The reason why this is both consistent and available, or at least you can ensure that you can have both consistency and availability, is because you have no chance of partitions occurring, because there are no multiple nodes. The only way that you can have partitions is if you have a distributed system. If you have a singular node, then you are not, by definition, a distributed system, meaning that you do not even need to think about partition tolerance because partitions don't exist. So in this type of scenario, then you have a consistent and available system. So this rounds out pretty much what CAP theorem is. Now, when you choose whether you want a CP or an AP system, meaning you either get a consistent and partition tolerant system or an available and partition tolerant system, depends on the context of the problem you're trying to solve. And this decision comes down to the database you choose to use, whether you use a SQL or a NoSQL database. Now, another way to view this is where we talk about acid and base databases, which is very similar to CAP theorem. It's the extension, and it's the same creator of the CAP theorem, or the writer of the CAP theorem, Eric Brewer, who discusses acid and base properties of databases, and that's what we're going to cover in the next video. But before we move on, I want to make sure that you understand what CAP theorem is and what consistency, availability, and partition tolerance are in a distributed system. If any of that is unfamiliar, please rewatch these last two videos and rewatch the appropriate sections inside of that database and SQL course that we just discussed. If you're ready, let's move on to the next video where we'll discuss acid and base properties when it comes to databases.